let's look at solving equations in quadratic form. At first glance, you might not think they're in quadratic form. Maybe they're in disguise. Check this out. The entire fraction 1 over 3x squared minus 4 times the entire fraction 1 over 3x minus 5 equals 0. This looks kind of tough. X in the denominator, having to square it. Woo! Well, check this out. In the middle, we've got 1 over 3x. To the left, for the first term, we have that same thing, 1 over 3x squared. Just like this. Here's b times something, and a times something squared. So it is in quadratic form. Let's pick another letter to use for a substitution. It's usually best to pick a letter not already in the problem so you don't get confused. That's up to you. I usually pick a different letter. So I'm going to go with the letter N. There are 25 other letters in the alphabet besides X, and you can even draw an animal if you want. We'll make the new variable equal to what is in the middle. That's that 1 over 3x. It's to the first power here, and it's squared over here. We'll make our new variable equal that. So N is going to equal 1 over 3x. We're going to substitute N in for 1 over 3x. You see it happens twice. And there's our new equation. N squared minus 4n minus 5 equals 0. Remembering that N is 1 over 3x. Let's go back. And this is much easier to solve. We did have 1 over 3x in the middle. Now it's N, because N is 1 over 3x. We did have 1 over 3x, the whole thing squared. Now it's N squared, because N is 1 over 3x. So that's the difference. What it used to look like, what it looks like now with N inside. And again, this is much easier to solve. Choose whatever method you like, but we can factor this. We'll get rid of those parentheses to neaten things up. N squared minus 4n minus 5 equals 0. That factors into all of n minus 5 times all of n plus 1 equals 0. That gives us two solutions. N equals 5 and n equals negative 1. All right. But we're supposed to solve for x. Just because we found n doesn't mean we get to throw a party yet. We're not done. We still have to solve for x. There wasn't even any n in the problem until we put it in there. Remember, n is 1 over 3x. And now we've got two values for n, 5 and negative 1. So, we're going to take n equals 1 over 3x and put 5 in for n and put negative 1 in for n, because we know that's what n is. Now we can solve for x. In both of these equations, I'll multiply both sides by 3x and then divide as necessary to get two solutions, which is what we were expecting. X equals 1/15 and x equals negative 1/3. Those are the answers to our original problem for x. If we plug either one of those in, they work. So we're using substitution to make our lives a little easier. Here's another that might look like it's not a quadratic equation. You don't see anything squared here at all. But in fact, in disguise, this is a quadratic equation. It looks pretty tough, especially with that square root of x. That doesn't look like it would be any fun to factor. But let's take a closer look. The square root of x is in the middle, and just x is on the left in the leading first spot. Remember, x is the square root of x squared. So we do have something here in the middle, and that's something squared on the left, just like we have here. B times something, a times that something squared. We have 4 times something, and here is that something squared. That something is the square root of x. We're going to use substitution again. Again, I recommend picking a different letter. I'm going to use n. Once again, it's different from x. And I'll make n equal what's in the middle, the square root of x. And that's going to help me substitute. Now, Again, reminding myself, this x on the left is really the square root of x squared. So that's the first change I'm going to make. That still is x. The square root of x squared is x. Now we're ready to plug in n. N equals the square root of x. So in this spot in the middle, we'll put n, and over here on the left, we'll put n, which will give us n squared on the left and 4n in the middle. Take a look again. It used to be the square root of x. Now it's going to be n. This used to be the square root of x squared, so that will make it n squared. And this is much easier to solve. In fact, it's really easy to solve because we already did solve this earlier in the video. We already know what's going to happen. N's going to be 5, n's going to be negative 1. But remember, we're not done. We're the ones who made up n, and we're supposed to solve for x. So let's plug in for n and discover what x might be. N is the square root of x, and n is 5, n is negative 1. So we're going to take 5 for n and plug it in one time, and plug negative 1 in for n another time. 5 equals the square root of x. Negative 1 equals the square root of x. We'll square both sides and get that 25 equals x, 1 equals x. Two possible answers. Remember though, we did square both sides of an equation. That's like building a doggy door that allows dogs in, but it allows squirrels and rabbits and other animals in as well. We've introduced the possibility of extraneous solutions that are not really true. And the leading term here has an exponent of 1. This is a first degree equation. I'm really only expecting one answer to work, and we've got 2. So we better check them. Let's start with x equals 1. We'll plug it in. 1 minus 5 is negative 4. Negative 4 times the square root of 1 is negative 4. Negative 8 equals 0 is not good. So x equals 1 is not a solution to this problem. We did all of our math correctly. It just works out that n is not possible. Let's check x equals 25. We'll plug it in for x. 25 minus 5 is 20. And the square root of 25 is 5. We're going to get 20 minus 20 equals 0. That is true. We found a winner. The solution to this problem, the only solution, is x equals 25.